In this lecture, we are going to learn about the symbolic constant and how we can create our own constant using the const keyword. So to achieve this, let's try to write a program to find the area and the perimeter or the circumference of a given circle. So I've already done a program to find the area in one of our previous lectures. So first let's note down what is the formula for finding the area of a circle. So area of a circle is nothing but pi r squared, pi times r, and its circumference, the formula for the circumference is 2 times pi times r. Okay, let's try to write the program to compute the area and the circumference of a given circle, and while doing so we'll be learning how to use the concept of symbolic constant and the const qualifier or the const keyword. So first of all, we will have to have some variables. Okay, so I'll have a variable called as r for the radius. So I'll ask the user to enter the variable. So enter your radius. So my variable is the radius. This is the message I give to the user, and now I'll scan this because I'm scanning a floating point value %f inside double quotes and then comma ampersand r. So my radius is scanned now. Okay, now I'll have to come to the processing part. Now how do I find out the area? So again I'll be needing some more variables, one variable for storing the area, one more variable for storing the circumference. So I'll just write circum to store the circumference of the circle. So once the radius is scanned from the user, once the input is done, so I'll find out the area. Area is pi r squared, 3.14 is pi times r. This is the formula. Okay, and my circumference is 2 times pi r, right? 2 times pi is 3.14 times r. Okay, this is how I find the area and circumference. So now I'll display the output. So I'll write printf area is %f. Okay, let me display up to 2 decimal places. So I'll write 0.2f. Okay, %.2f, or I can write %0.2f area, and circumference is %0.2f. So up to 2 decimal places after a decimal point. So I'll write area comma circumference. Now this printf will be able to display my area and circumference of a given circle. So let me compile this code, gcc constant1.c, and let's execute this. Let me enter the radius as 7 units and the area is 153.86 and the circumference is 43.96. It works fine. Now let's see where we can actually apply the symbolic constant. Now if you just come to the formula, line number 17 and 18 is actually using the same constant, same value, that is 3.14, the value of pi, the constant. Pi is constant, right? Now it is coming for 2 times. Let's say I would like to modify pi, because pi can have this is the value of pi up to certain decimal places. So if I want to write pi up to 4 decimal places, I can write 3.1415. Okay, so if I have to change this from 3.14 to 3.1415, I'll get more precise answer. I have to do the changes 2 times. Okay, and if my pi constant is repeating in my program for 10 times, and I have to replace this value of pi manually for 10 times. Okay, that is one of the problem. Now to fix this, what I can do is, instead of actually using a pi here like this as a constant written down as 3.14, we can use a symbolic constant. So now in order to define this symbolic constant, I can do this using hash define. This is a preprocessor directive. Okay, I have to do this hash define in a single line, obviously like my header file, and it should come before my main function at the beginning of the code. Okay, so I write hash define, and I have to give the name. I write hash define, I give a space, then I have to give the name of the constant. So symbolic constant will give a symbol to your constant, a symbolic name for your constant. Let's say I give the name as pi. So generally symbolic constant is given in uppercase. It is not a rule, but it is a convention used by almost all the programmers. Okay, so I give the symbolic constant as pi, and then I give the value 3.14, let's say 3.14, and in your program you just write, instead of 3.14 you write pi. Okay, similarly here instead of 3.14 you write pi. That is my symbolic constant. Okay, here I can say that pi is my symbolic constant, that is defined here using hash define. Now this is my pi. Now let's try to run this code. Okay, compile it first, and then let's say the radius is 7 and the area and circumference is displayed. Now if I would like to change this value of pi from 3.14 to 3.141592 up to these many decimal places, I just do it once now. I need to just change the value of pi once, and now it will be reflected everywhere it is occurring. Okay, now at line number 17 and 18 the value of pi will be replaced by this new value of pi. Okay, so let's try to compile this code here, and let's try to run this, and if I give 7 I get a new value of, because I have more precise, more accurate pi now, so the value of area and circumference is also changed accordingly. So it is 153.94 is the area and circumference is 43.98. Okay, so this is how symbolic constant works, and we have already used some of the symbolic constants in one of our previous lectures to find the range of a given data type. Okay, from limits.h header file. So if you can recall, we have written down something like this, limits.h, and then to find the let's say upper limit of int is let's say %d. Okay, and I write int max. If you just look at this int max, this is actually defined as a symbolic constant using hash define in the header file limits.h. Now if I actually run this code here, compile and run it here, okay, so let's talk about the radius is this one, and you see the upper limit of int is this one. Now this int underscore max is a symbolic constant defined using hash define in the header file limits.h. Okay, this is symbolic constant. Now how does symbolic constant work? Now symbolic constant actually works during the pre-processing phase of compilation. So compilation process is a complicated process which has a lot of phases, right? So how does it actually work is, it is not going to create a variable kind of a thing, a box kind of a thing where the value 3.14 is stored and then it is fetched here in line number 18 and 19. It actually works by replacing the value. So the thing that happens in pre-processing phase is that, during the pre-processing phase, this pi value is copied, and then wherever pi occurs, there this value is replaced by. It will be replaced by the compiler for us. Okay, so it is as good as writing this one. So this is how it works. Okay, this is how it works during the pre-processing phase. The pi symbol would be replaced by the value of the pi that is occurring here, and it is not going to create a separate variable box storage unit for storing the pi. Okay, this is how symbolic constant works. Now let's learn about the const qualifier. You can also create a constant using a const qualifier. Let's say I would like to create one constant. I write float. If I write float, pi is equals to 3.14. I have given this pi small letters. Okay, generally variables are in small letters. This is a simple variable. Okay, now if I would like to make this as a constant variable, generally we make a variable as a constant by giving a const qualifier, const keyword, that is a reserved keyword in C, just prefixing the data type name. Just before float I give const, so this will be a const variable. Now the very important thing for const variable is that let's just try to write const float pi, and then if I write here pi is equals to 3.14 for example. Let's see what happens. Let me compile this code. Okay, so what is it saying is that it is saying is that pi is small pi is a read only value, so you can't assign the value, any value to that variable. So it's not a variable now, it's become a constant. So constant cannot be redefined or reassigned the value. So whenever it was actually declared, there itself you have to assign the value. Let me print the value of pi equals to %f, okay, and I give pi, and let me just comment this line because this is giving me an error. Okay, so let's compile this code, and then there's no error. Okay, and then now you see by default the constant is taking the value 0. So pi is by default taking the value 0. So initially just for one time initially while declaring itself, I can assign the value of pi as 3.14. Okay, now if I do it now like this, let me just get out of this program and then compile it again, and then now run it. See, now pi is 3.14. Okay, so now pi is 3.114 and it works fine. Now if I try to replace this with some other value 3.141 here, okay, and then try to compile my code, and then see, it will tell me that assignment is not possible. So constant is like a variable. It will take a storage unit. It will reserve a box wherein the value will be stored. But the point to be noted down is that this will be only treated as a read only kind of a variable. It's a read-only variable. That means once it is assigned, it cannot be modified. So this is how the constant variable or constant can be created. Okay, once created, it can't be modified. That is what you should note. So you can actually make use of const and obviously symbolic constant wherever required in your program. Okay, so that's all for this lecture. Stay tuned.